When looking at the hammer throw, in order to truly understand what is happening in the movement, you first have to understand the forces at work. Newton's first law states that a body will remain in a state of rest or constant velocity unless acted upon by an external force that changes the state. The law of inertia applies to the stance phase prior to overhead winds. The law of acceleration states that a force applied to a body causes acceleration of that body. In the case of the hammer throw, this is when the ball is brought up into the overhead winds, as the force is accelerating the ball from zero and gaining momentum. It is also seen during the turns, where the arms and legs drive the acceleration faster and faster in each turn up until the release. The hammer is acting as an extension of the thrower's body in a way as it matches the direction and speed and magnitude of force that is applied throughout the turns. Newton's third law, the law of reaction, which states that every applied force is accompanied by a reaction force. In this case, every time the foot lands in double support, the ground reacts by generating an upward reaction force. Momentum is a factor that is made up of an object's mass and velocity. Momentum is caused by the thrower pushing or accelerating the ball throughout to the low point and back around to the catch. Impulse, which is the product of a force and the time interval over which the force acts, could be seen as one of the factors for major errors in the throw. In the last video, head whipping was discussed. When the head moves prior to the rest of the body, the hammer is pulled from behind the body rather than in sync and can cause late footfall or catch, which in turn can affect the orbit of the ball, slowing down momentum rather than maintaining it. In order to prevent the head from whipping, the thrower must stay in the triangle, meaning they keep their head in the direction of the hammer and using the lower back muscles and abdominals to prevent sideways movement. Torque is the rotary effect created by an applied force. The amount of torque generated is typically affected by both the magnitude of a force and the length of its movement arm. Joint torque is when a muscle crossing a joint develops tension, producing a force that pulls on the bone to which it attaches, thereby creating torque at the joint the muscle crosses. This is mainly seen in the shoulder joint. The axis of rotation in the hammer throw comes from the legs and feet pushing into the ground. The force is the hand gripping the handle, and the resistance is the hammer itself. The center of gravity is slightly lower than usual, as the thrower is in a quarter squat throughout the movement, up until release. Stability and balance is maintained throughout the movement by keeping the center of gravity level and moving body weight from equal between the legs to stable on the left leg and back. Weight is shifted by switching from the heel to the toes on the left foot, and on the right foot you remain on your toes in order to avoid rocking onto the heel and throwing off the rhythm.